Okay. I have the pleasure of being one of the last speakers, so hopefully people are still awake. I'll try to speak loud, so maybe I can keep you awake. I don't know. If you want to take a nap, I'm not going to be insulted. Okay, so my topic is the future of data centers, safety, and cybersecurity. I've been teed up really well with the discussions at the beginning of the day. What Michael and Stephen were talking about, actually, David also talked about a little bit too. There's a significant amount of overlap here, and I'm going to try to touch on some different topics that we've had as themes, and then talk about a little bit of solutions from the standards and regulations point of view. So I'm going to talk a little bit, really briefly about myself. I'm not going to go through my resume or anything like that. I just want to say that I've been at UL for the last 8 years, but I spent the beginning couple decades of my career actually developing these products. I was a customer of UL's. My first job out of school was actually designing PLC software and application code and so forth. And there was a couple of horror stories I thought of when David's talk and also at the beginning of the day with Michael's talk, where I was working on, Siemens and Rockwell and other PLC types like that. And people were just plugging in an Ethernet cable just because they could, right? And then we're talking 25 years ago, right? And they were doing this, connecting it to a network just so they could try to access it remotely. Those products were not designed for that, right? And over my career, I've had the opportunity to develop software from a functional safety point of view, and I was really happy to hear Michael talk about that earlier in the day. I think that's fundamental to understanding also security, is that if we don't build it right in the first place, vulnerabilities is a secondary concern. And I think Luis was kind of alluding to that a little bit in your question, where if you've got a bad product, you still got possibly a vulnerability at the lowest level. The networks can mitigate, I think, some of that, but I will say that it is important to have the functional safety and cybersecurity covered at the component level too. Otherwise, it's garbage in, garbage out, right? Problem. So. All right, so I do not have data specifically on data centers yet about the number of vulnerabilities. So these are some of the residential numbers, but it gives you an idea of the frequency of attacks that we see on a daily basis, right? Basically, if you think about 46 devices per household, imagine multiplying that out into a data center with 8 attacks every 24 hours on your home, right? So, and your assets are not nearly as critical as what's going on in a data center, right? So you can just imagine how often that they're trying to get into those more critical assets, all those malicious actors and also those that just want to prove that they can do it, like David was talking about a moment ago. The other thing that's happening is the proliferation of all of these new different endpoints, new different access points. As we try to build more smart systems, we try to get more data, we create more connectivity, which creates more vulnerabilities, right? So we want more data to go into AI to make these inferences on systems. We're trying to reduce downtime on a major power plant or a steel mill or something of that nature. Well, in order to get that data, now we've connected new points to legacy systems that maybe weren't connected in that way before. So it becomes easier and easier to get access to it. I would say that in general, AI workloads are driving a lot of this change. We're seeing also AI drive more, let's say, horsepower into cybersecurity. And what I mean behind that is, imagine the difference of cutting your grass with, a motored lawnmower versus one of those push mowers, right? I mean, you're going to get a lot more done when you got a motor on that thing. And that's what AI is doing with vulnerability, with hacking and so forth. You could go into one of these GPTs right now and ask it to build you some type of source code that will exploit a vulnerability on a piece of the devices that you're working on today, and it'll spit it out in less than a minute, right? And that was something that somebody as a software engineer, someone that when I started out my career, it would take, maybe a day, right? You're reading manuals and so forth. And so going from a day to a minute is a huge escalation and whatnot. And so I think that's one of the aspects that we're trying to deal with from a cybersecurity, from the blue team or white hat perspective, right? The cyber physical realm is also something as we get, I mentioned the more connected systems, but also we're dealing with higher power. we're dealing with larger infrastructure, right? I mean, there's heating management, there's cooling, and all these types of things. So data centers themselves introduce new types of threats that we didn't have to deal with before. You can put a vulnerability into a cooling system and be able to catastrophically fail the data center, right? Data and so forth. You can find the vulnerability in the power management, the batteries. There's so many different points to go after. You know, it can be an inverter. So there's a stack of all of these different devices that all can lead to catastrophic failures. And the higher the power, the more critical it becomes. Safety and operational resilience, I talked about how fundamental this is. There are standards, even as UL Solutions and the standards bodies that we participate in. There are standards around cooling, there's standards around safety, there's standards around functional safety. And those lay a foundation that's important. But the problem is that as we cross over between IT and OT, a lot of those legacy assets in the OT space knew about functional safety. They knew about criticality levels. They had risk-based frameworks that were based on standards. A lot of the IT folks were not dealing in that space. And so they're not necessarily building risk-based frameworks for development, right? They don't always have a risk assessment that they've done, either from a safety perspective or a security perspective, right? And so you're transitioning from that Silicon Valley mindset into those legacy types of products and assets. And in some ways it's a conflict. And so if we try to just mitigate the issue in the network, you're dealing with folks that maybe don't have the right knowledge. And that's where they'll go to consulting organizations, right? And they're gonna try to outsource that information, but now you're lagging behind change, and that's the challenge. Electrical and cybersecurity. So one of the things, you know, my team and parts of UL Solutions, we try to do is look at some of the existing product safety standards. We look at regulations and so forth that are coming about and think about, well, what happens if a cyber vulnerability can introduce a safety risk, right? So what happens if that inverter system, for example, can be attacked and lead to a failure of the energy system? And so because of that, standards for safety, like UL 1741, have now included some, for now, optional references and so forth to cybersecurity standards to have that consideration in your mind. And as National Electric Code starts thinking about these things too, they're also making considerations to making updates to reference existing cybersecurity standards as well. So there's this bridge that's happening between safety and security, and it's a challenge because there's a lot of really great knowledge on cybersecurity that comes from, let's say, IT management domains and so forth that maybe didn't have to deal with safety integrity levels and things of that nature. And vice versa. There's a lot of people that were in the compliance world and safety risk-based frameworks that don't have the knowledge of networks and infrastructures and data protocols. And so you're trying to marry those things together. And it's very rare to have people that have all of that experience because, you know, you need decades in both realms, and it's not as common to find both. That's why I know that some of the folks here that I talk with on a regular basis at Eaton are trying to source those that talent here as well. I think there was some recruiting happening earlier this morning as well. So I brought this one up. I've used this slide a few times, and there's a lot of standardization that already exists today in a lot of the products, right? And so we're going to start on a product basis and then kind of go bottom up and then top down. So bottom up, I'm thinking about individual products that we deal with. And on the consumer side, we're pretty familiar with some of these things that we deal with on a day-to-day basis. Your watches and so forth can create vulnerabilities, and there are standards that exist for those. And a common example is EN 303645. And the reason I bring this up is that a lot of your IT equipment goes through standards like these. Now, these standards on the left-hand side are good standards. There's nothing wrong with them, but they're not necessarily built for the higher criticality systems on the right. And so you get a little bit of a conflict where you got something that was good enough for an IT space, and now you're using it in a safety critical application. Think about, for example, you have your laptop, right? And using it on your desk in your house is very different if that laptop is now controlling large 800 volts DC, right? It's a big difference there. And so standards like IEC 62443 on the top there, that was built more for those OT systems that were controlling high power and things of that nature. And so you're taking IT equipment and you're putting it into those spaces now that are safety critical, and you're not often using the same standards bases. And so that's where we run into sometimes a little bit of a conflict, because these standards, other than medical, which is a different story, and we can talk about that over a beer rather than in this context here. But 303.645 is not the same as 62443. They're both very good standards, but they're intended for different applications. So we should be aware of that. If you're sourcing components, if you're a system integrator, for example, and you're getting a network switch or router and so forth, and it has been certified to cybersecurity, is it certified to the right type of cybersecurity? Is it really going to understand the level of risk that's associated with the application, right? And that's something I just want to plant a bug in all of your minds and so forth to think about, because I know there's a lot of people here that are responsible for managing that level of security within the assets and system integration in the products themselves. So the threats landscape continues to evolve, right? The challenge that we have, I just showed some of those standards. There's so many different standards. It's a fragmented landscape. It's hard to really navigate all these things, and then that also leads to regulatory mapping and challenges as well. We just experienced a big rush for the Radio Equipment Directive. How many of you are familiar with Radio Equipment Directive? Raise your hands. All right, a couple hands, right? So in Europe, there was this requirement for anything that had a radio in it. It could be Wi-Fi, it could be 3G, Bluetooth, whatever, or 5G. Any of those types of things had to go through wireless testing, like electromagnetic compatibility, but also cybersecurity. And so as of August this year, everybody had to be compliant. And so there was a rush from all of these product manufacturers to be compliant with RED. I know Eaton was dealing with that challenge too. UL Solutions was working with them, and we work with other clients like that to understand how do you comply with that. The challenge is Europe released this regulation very quickly without a lot of notice, and all these manufacturers are struggling to map to it when there was already all those other standards that existed before. And so now you're trying to map to a new paradigm, and all of a sudden there's a new regulation coming out, Cybersecurity Resiliency Act, which we talked about, and it's a whole new paradigm that doesn't necessarily build on RED. It's going back to the legacy paradigms again. And so it's a little bit of a flip-flopping there, and that's not to mention the US that hasn't really directly published guidance as of today that comes anywhere close to the level of formality that we're seeing in Europe. And so that leads to the challenge of the manufacturers that are developing global product portfolios, that you have certain guidance in Europe. Do you create the same solution for the US when there aren't regulations in place? So maybe you're over-engineering a solution for a different market, or do you try to make a national deviation between the product designs? And now you have more SKUs, more products to maintain, and it creates additional complexity. And so there has to be some balance and trade-off, and I know that a lot of the folks in this room are dealing with that challenge today. And that leads us to this limited access to market intelligence. There's not, let's say, a published database that's really reflective of the current state of all of these standards, all these regulations. As UL Solutions, we have some tools that we try to publish, but that's always a lagging indicator. The governments themselves are still working on their guidance as well. And so we don't have up-to-date information for a product manufacturer to get everything they need all at once. So, we'll often engage in advisement and so forth with individual clients as we help them navigate through this, but the goalposts keep moving, right? We just had Radio Equipment Directive. I mean, August was 2 months ago, right? I mean, it's not that long ago, right? And now CRA is right around the corner, and we're dealing with that. And who knows what else is out there? The machinery directive has now been updated to machine regulation. So for those of you that don't have to deal with that, imagine large-scale robotics in a smart manufacturing deployment would have some type of connected systems. Traditionally, it had functional safety built in, which means you had a risk-based evaluation of the safety functions that are built in. Don't have that robot arm crush somebody, right? Now there's also AI and cybersecurity requirements being added to that regulation as well. And that's coming in Europe. So there's more of these regulatory demand drivers that keep getting released, and we continue to try to figure out what's the appropriate level of security for the appropriate level of risk that we're dealing with. So I've talked a little bit about some of these things like the high power densities. There's targeted control systems attacks. So my horror story about, when I was starting to do development and they were plugging in those Ethernet cables, those types of products have not traditionally been designed for security. I mean, you talked about it earlier in some of the discussions here. You might have legacy software that's been out there for 20, 30 years, right? And so that might be a targeted attack because you might still be even using default passwords on these devices, right? I mean, people just weren't thinking about security in this way back then. But now we layer on additional threat levels, right? Now we have these CUDA-X types of deployments and GPTs and all this very fun and interesting types of platforms, but it creates additional attack surfaces, right? There's additional access points to the data. As you're taking, let's say, an interface to all the information that you're processing from the data centers and so forth, that may have some type of platform where you're sharing that information and so forth, right? And so can somebody get in that way, right? Access the application that's being created. And it might be a Power BI dashboard, or it might be something that's custom created. There's a lot of different ways to get after this information now. And the more layers we add, the more vulnerability points we add. And then finally, new risks require cybersecurity strategies to integrate physical safety and operational resilience in AI factories. So what I mean by this bullet point is that the physical security is bleeding over into cybersecurity and vice versa. I talked about earlier, cybersecurity threats can lead to safety issues. The physical security as well, as we know, many of these types of vulnerabilities are through social engineering, right? People are actually physically accessing a device, they're getting in there. So how are we preventing access to the system itself? Do we have access management controls, authentication procedures, and so forth? And not enough consideration, in my opinion, gets put into the infrastructure around the systems we're trying to protect. Because what I think David was saying it earlier, once you have physical access to the device, you've got a problem, right? And so I think sometimes that gets undervalued in the whole discussion. So when we talk about what's at stake, so I mentioned this briefly earlier. Imagine you have these higher voltage systems. You've got 800 volts DC plus in some of these places. That is a level of voltage that can create a safety risk for people that are within proximity. It creates a risk that the actual data that you're housing can be destroyed, right? Because if you can somehow, through a cyber breach, manipulate those DC systems that are in the data center, you can create a safety risk, you can create a vulnerability for the data itself. There's also a lack of standardized safety models as well. NFPA has been looking at these things. The National Fire Protection Association, I believe, is the acronym there, right? And so they are looking at ways to harmonize strategies, but fire protection traditionally did not have cybersecurity experts, right? There's a different type of forensic analysis being done there. You're talking about chemical and material safety and things like that, right? And so, you're trying to blend chemical engineering with computer science. They're different disciplines for the most part, right? And so you don't just flick a switch and automatically have that knowledge. And so, there have been questions to my team and related teams around what should the NFPA be considering from a cybersecurity perspective? Could we start a fire with a cybersecurity breach, right? Is the short question. And I think the answer is yeah, in theory, right? If you got access to the right types of products within the data center, you could start a fire, or worse. And then I talked about the liquid-cooled cables, breaker performance. Breakers also, if you've got access to a breaker system and you put some malicious code there, or you prevent it from acting the way that it should, if it doesn't trip when it's intended, Again, another fire and safety issue. So there's a need for cybersecurity assessments that can address some of these physical safety issues and the gaps that are in these standards. So I'm going to give a really high-level overview. I saw a lack of hands when I mentioned some of the things earlier. I'm going to try to take a poll here on some of these things. How many people have been dealing with Cybersecurity Resiliency Act so far? Again, I see about 6 hands. I'm very surprised. In the EU, there's a regulation called the Cybersecurity Resilience Act that's going into effect as of 2027, right? And so manufacturers are spending the time between now and then to try to go through this process. And while the technical requirements are not yet fully formalized, the product-related essential requirements and the vulnerability essential handling requirements, those are some of the technical details of actual vulnerability management. But right now, everything starts with the risk assessment. And I think David said it earlier too, getting into risk-based frameworks is how many of these standards and regulations work, right? And that's how we should all be thinking. What is the risk we're trying to mitigate? Is it access to the data? Is it fire? Is it electrical shock? Is it all of the above, right? But the mitigation might be different depending on the risk. How we prevent a fire might be different than how we protect the data that's in the data center, right? And we have to think about there's different mitigation mechanisms that we're going to use. A lot of the access to the data might be done through the network controls, but a lot of the fire protection might be through the actual products themselves, making better selections for products, replacing legacy components. That might be more costly, but what's the cost of burning down one of these data centers? You have to balance out that risk trade-off. What often doesn't get factored in is a cost of non-compliance, right? What is the cost of that fire and so forth? So risk assessment, vulnerability, product-related essential requirements, that will lead into a conformity assessment. So the expectation of the EU is that manufacturers are going to do a risk assessment, they're going to evaluate the technical requirements, and they're going to go through some type of assessment, right? And so depending on the criticality level of the product will determine whether you need a third party, a notified body, like UL Solutions, for example, or if you can do a self-assessment, if it's a lower criticality of product. It really just depends, and that's where the risk assessment is critical. It's going to determine the level of rigor you have to put into the system, and it's going to determine the level of formality you put into actually proving that you did your homework correctly. And then vulnerability handling. So the thing to keep in mind with cybersecurity, as we all know, it's not just a point in time, right? It's not like product safety evaluation where we evaluate a version of the product and that version can stay static and maybe we never change it for 20 years and it's deemed compliant. Cybersecurity vulnerabilities is another moving target, right? And so we have to have a mechanism for handling vulnerabilities. There's always going to be a vulnerability eventually, right? If the product's out there for 10 years, there's going to be something we didn't think about, or 20 years and beyond. How many of you have been to one of these industrial sites and seen a piece of equipment that's been installed for 20 years plus? Raise your hand. A lot more hands this time, right? And that's common, right? And now, if it's got software in there and so forth, you could just imagine how quickly that software becomes obsolete. So the EU is asking you to have a method for vulnerability handling, and then there's going to be an obligation to report through a single reporting platform. That's still a work in progress as far as what exactly that platform is going to look like. We get some of these insights through our engagement with committees like the TIC Council and also directly with certain working groups for the Cybersecurity Resiliency Act. So again, this is still something that's being formalized, but I do want to make sure that we have a level of awareness, because if you're not dealing with this directly, then probably your clients and customers and so forth are dealing with it. So then what that leads to is a need to have certain types of frameworks to deal with this, right? If you're going to have to do conformity assessment, you need to show that you did your due diligence. And the way to show that you did your due diligence is through traceability, right? And normally we would take a standard is a great way to do that. You can take some type of industry standard and then you walk through the requirements, and then for each requirement you may have a test or some type of analysis that you've done and so forth, and you can show that you've done the right things to try to mitigate the risks you've identified. Existing standards include IEC 62443, How many have dealt with IEC 62443? All right, a handful, or maybe the rest are asleep, but either way. 62443 is probably one of the most common in the industrial space. It has requirements at the product level all the way up to the asset level. And so you're going to see that very commonly in the industrial space. UL developed 2900 to cover a lot more products from consumer to medical and also things like building access controls and so forth. So covering some of the gaps that are non-industrial from that perspective. So as we look at the data centers and the new stress factors that we're going to deal with, we may have to update which standards we look at. You may have just been thinking about IT security. You might be looking at your IT management system like 27001, and so maybe you've got good documentation control procedures and you've got good version control and all of that, and that's great, but you may have forgotten to think about the vulnerabilities of the actual products you're protecting. So this is going to lead to mandatory security integration and component certification expansion. There's going to be a need for cybersecurity on a component level that we didn't have before, because Cybersecurity Resiliency Act is going to force that from a European perspective, right? And so it's something to keep in mind as you go into this. In the past, cybersecurity was something to think about in many of these categories. It was a liability thing, right? We talked about financial loss, right, in David's presentation. Now it's going to be a compliance issue, right? And so it becomes mandatory at that point. So 62443, just for those that didn't raise their hands, right, is a layered standard approach, right? We have general requirements in the -1. We have policies and procedures in -2, which will also include some of the requirements on the systems. And then the system integrators will be concerned with -3. And then the component and product requirements are in -4. -4-1 is a development life cycle. So how do you develop the product in a secure way? -4-2 are technical security requirements. There are programs that will dictate how you show compliance to this. So IECB scheme, it's too many letters and it's too late in the day for me to say all those. But the CB scheme covers this standard from an assessment and evaluation methodology. ISA, the International Society of Automation, also created ISA Secure, which is a program that also adds in a formalized way of demonstrating compliance for this that also prescribes testing for this as well. So the standard itself is an assessment methodology that uses security levels and then an organizational maturity model to determine, okay, if there's a certain criticality of the product, it'll have a certain security level, right? That's the amount of risk, and that's going to dictate the amount of mitigation we have to do, the amount of engineering rigor that has to go into the design of the product to mitigate that risk. And then we'll map our organizational maturity as part of that and our development life cycle and so forth. As another risk factor, I wanted to mention distributed energy and inverter-based resources as one of those types of products. This is a standard that's been in outline of investigation, UL 2941, for a couple of years now, and has actually just completed consensus voting and balloting, and should be released within the November timeframe. So it's coming into play next month, in a couple weeks, and covers inverter-based cybersecurity. So if you're dealing with inverter manufacturers, if you manufacture inverters yourselves, and so forth, this is going to be something to consider. And so while 62443 often is looked at from an infrastructure perspective, from a standardization point of view, there are individual component level standards as well for cybersecurity, like 2941. And you can see some of the topics that this type of standard covers, from cryptography, secure data protection, the management, from security management, risk management, and so forth, all the way down into anti-tamper and annexes on how to implement this standard. Within the same vein, there's also the access controls. So how do you get in to the data center? How do you prevent unauthorized access and so forth. So building life security systems, your signaling, your alarm systems and so forth. UL also has a standard 2900-2-3. And again, I'm not just advocating UL standards, I'm just trying to show you different aspects of the system to be aware of from a security vulnerabilities point of view, right? So there's the products like the inverters and the energy systems and so forth. There's the building access itself, and then there's the infrastructure that will be more of the 62443 types of methodologies. So there's different layers of security that we can look at as we look at the data center as an asset, right? The actual building that has heating and cooling and things like that, and the data center as a product itself, right? That's generating data that needs to have uptime and so forth, just like you would a manufacturing operation and so forth. So suppliers will need to design secure products. As supply chain is going to have more and more requirements coming to them because of additional regulations like Cybersecurity Resiliency Act. So suppliers to Eaton as a supplier, as examples, they're going to have to deal with more mandatory compliance frameworks around cybersecurity. And so it's something you need to be aware of and also to be selective of as well. If people are going to be dealing with these standards, there's a value add to you, if you're a system integrator or an asset owner, to not have to go and take on that responsibility yourself to verify the security of the component. Buying and sourcing secure components should be part of that strategy if they exist on the market. Secure by design, it's a principle we talk about everywhere. I don't want to beleaguer that point because I think we talked about it in multiple different presentations so far. The customers themselves. So something I heard also when Stephen was talking from Siemens Energy, not Stevens Energy. I don't think he owns the company. But he was talking about the idea that they're transitioning not just from an OEM, but also a system integrator in a way. And one of the questions I wanted to ask, but I didn't want to get stuck here for 30 minutes while he was answering just my question, is how are they educating the users of these systems, right? Because there's a lot of that security responsibility that gets taken on by the asset owner, the people that are actually supporting these plants and systems, right? And so if you're maintaining a data center operation, how are you maintaining your security posture? Somebody like Siemens and Eaton and otherwise might come in with certain solutions for you, but at the end of the day, you're interfacing these OT systems with IT systems, and their IT systems may not have been built with the level of security criticality that's needed here. It's again that kind of transitioning between that Silicon Valley mindset to the critical infrastructure mindset. They're just different approaches, right? We don't want to move fast and break things when we have billions of dollars of data in that building, right? So that leads to a need for training and awareness. There should be more training on the safety of these systems, and it's training of the users of the equipment, it's training of the designers of the equipment and so forth. UL Solutions try to participate in that by developing standards-based training and regulatory trainings and so forth. So we have CRA, Cybersecurity Resiliency Act training that we do, UL and IEC standards. But I would urge you as system integrators, product manufacturers, and so forth, to also educate your customers to make sure they understand what are they buying, what is the benefit of secure by design, not just at the product level, but at the asset level. So maybe I went a little too fast, but it looks like I've got a few minutes left here. Again, I just wanted to make sure that I highlight some of the things that are coming down the pipeline. And there's regulations that are driving this demand. There's high criticality systems. And so hopefully, this helps to open your eyes a little bit for those of you that, your eyelids are getting heavy at the end of the day here, to all of the different challenges we're dealing with from a data center perspective. I'm happy to dive into details on any of that, either through questions here today or after the fact, my contact information. You can reach me directly, or we can meet up at the Rock and Roll Hall of Fame later too. So,
great presentation. I think it touches on a lot of specific things that we from Eaton have to deal with, and you know that very well. I think the point you made at the end is essentially, in my mind, is the heart of what I was asking before, when we need to deal with the equipment itself beyond just network traffic. And all these regulations like CRA create mechanisms for the equipment to be upgradable, to address vulnerabilities through the life cycle of the equipment, address a lot of the legacy problems that we've been discussing. And the question is, this is as good as people, I think that's what you're implying at the end, this is as good as people having the knowledge and taking the advantage of those regulations. We can, Eaton or any other company here can build the equipment and comply with the CRA, but if the customer or the manager or the facility that has that equipment doesn't understand the benefit of that, the capability of the equipment and that the manufacturer needs to be able to fix, patch, upgrade the software that's running on that equipment, and nobody takes action on those vulnerabilities that are patched, then that's is of no use to the end user or the equipment here. So I think it's more a comment than a question, but how do you see these training programs that you have at the UL? How do you see this driving the end user knowledge about what is becoming available with the equipment, the ones that have to comply with CRA? How do you see this education process with the end user becoming effective in driving the user to request the patches and updates there?
I think honestly, what we do scratches the surface of awareness. So I just did a webinar on cybersecurity regulations and the landscape and so forth. And we had, I think, over 800 people register for that event, when typically it's like 100 to 200 people, right? So it's a huge amount of interest is being drawn into this space. And I think that there's two things that start changing the thinking. So we joked a couple of times today about all this legacy equipment running Windows 95 and things like that. And I've seen it myself too. But I think there's two things that cause those people to go and make the software updates you talk about and replace legacy equipment. One is CRA, right? An actual regulation that now comes into place that actually forces these asset owners, system integrators, and product manufacturers to now think about cybersecurity from a regulatory perspective. But the other thing that I think gets forgotten sometimes is in the effort to get more AI driven, to drive more automation and so forth, you need data. And these legacy systems that are running Windows 95 and so forth aren't going to give you the data that you need to make the inference that you want to then predictively measure when downtime is going to happen and prevent it and so forth, right? And so because of that, I think that that's going to be a huge demand driver that actually has a financial incentive for many of these organizations. And I think that's going to be probably even bigger than a regulatory demand driver, is the need for many of these assets to want to go more AI-driven decision-making, AI-driven forecasting models and so forth, whether it's on power management or data flows and so forth. So they're going to need the latest versions of the products and software to enable that transition to AI-driven. So I think that's going to be a bigger demand driver. So I would educate clients, consumers, and so forth on what that means to do that. We do that through functional safety training and cybersecurity training, but from a UL perspective, we're often just looking at the compliance view, right? Where I think that those types of financial impacts and so forth, that's a supplier to customer type of conversation that I think has to happen, right? I mean, they want AI, they want this new data, but they may not be realizing what they're asking for. Right? They need more intelligent systems, which then have more robust and complex software, and it's going to cost more, right, to replace those out. So that Windows 95 machine gets thrown out eventually, right, in order to get something that can actually interface with the network and give you the data that you need. We used to isolate everything, and that was on purpose, through obscurity, like we talked about before. But we can't be obscure if we want to have remote access and we want to have AI data models that with cloud computing and so forth, and all of that we're trying to enable. So the technology itself and the ubiquity of it, I think, drives the need for many of these legacy operations to now update the software and products. I think that's going to be the biggest demand driver. So if I was in Eaton's shoes, that would be probably the approach that I would go after, because a lot of these people, they only think with their wallets, right? At the end of the day. So, and we'll continue to do what we can from a regulatory standards perspective, and we're happy to partner with all of you on any individual engagements and so forth that might be helpful from an education perspective or anything like that as well. We do have software tools that we try to use too, so we're happy to use those solutions to help you as you're navigating this journey, because it's complex. There's a lot that's going on that I mentioned earlier, and it's a moving target as well, right? And so you can spend time adding resources and so forth, or you can also leverage some of our expertise to help you fast forward that knowledge gap. Mm-hmm. Other questions, if I have time?
I actually had a question if there's no more. So I liked at the end there how you kind of spoke about responsibilities. One of the things that I'll be honest, I personally deal with is knowing who does what. So can you speak to the importance of including those certifications and those requirements in specifications?
Yeah.
Because a lot of times, I'll just give you an example. At Eaton, we'll get a specification and it's not always clear. Is a customer's IT team doing this? Is a different, cybersecurity partner doing this or provider? And it's sometimes trying to figure that out on the fly. So you could speak to the importance of clearly defining what's required by the individual parties.
Yeah, that's a great question, and it's often overlooked, is that there's an assumption that's often built into either the asset owner's mind or the component manufacturer or the system integrator. They're always pointing fingers externally, right? That person needs to do this or that or the other thing. Something that I like to borrow from my personal experience is something we used in functional safety. So I'm going to borrow an automotive example. There's actually a tool that we use, we call it a development interface agreement. And it's basically a contractual obligation between the two parties. It could be the OEM, like let's say we're talking about BMW or Ford or somebody, or Toyota or somebody like that, and a supplier like Bosch or Zeta F or Eaton, for example, right? And all of these different organizations that they need to work with. And that basically defines a RACIC, responsible parties, who's the approver, who's going to support, and so forth, for deliverables. And we use this for functional safety that has very clear defined deliverables. And if you use a standard-based framework like 62443, for example, you can also develop a deliverables-based framework that you would have as part of your contractual obligation. So for example, typically the risk assessment is done by the OEM, the person that owns the product and so forth, because they know the application, right? If we're talking about a component might be out of context on its own, but when it's being put into an actual asset, now it has a certain use case that gets associated with it. And so it doesn't make sense for a component manufacturer on their own to do a risk assessment on the whole use cases, but it probably makes sense for the asset owner who knows exactly where they're going to use a certain type of sensor or PLC or whatever the case might be. So the risk assessment is a perfect example where you can kind of assign that responsibility, but then that's going to dictate those safety and security requirements downstream. And so now you assign those requirements to one of those suppliers. And so you build this RACIC, if you will, that will help to establish an agreement. And we used to use it as actually part of a supplier qualification process. So first on the front end, making sure that we knew what we were signing up for when we're working with a supplier. And then also as part of our PPAP, our acceptance programs that we would have, where we actually evaluate, did the supplier do what we expected them to do, right? And so we use that development interface agreement to confirm that. That's an example, right? You don't have to use that methodology, but I do recommend in general to have some type of agreement, from a security basis, who's going to handle what part of the security infrastructure is going to be handled by the asset owner versus the system integrator versus the product manufacturer. And I would guarantee that somebody's going to be surprised in that, right? There's going to be a certain expectation or assumption that was built into their head. It's like, oh, I assume that the product already handled this or so forth, right? Or I assume that the asset owner already knew about this. Somebody is going to be surprised along the way. And that's why it's important to have those conversations up front. And then maybe you end up making better selections of your suppliers at the end of the day. And you can use it as a market differentiator as well. So.